I'm going to present the Brazilian contributions to CMS, and I have to stress that this is a condensed view. I will focus on contributions in physics analysis, computing, and hardware, and mainly those that impact the current position at CMS and the status of Latin America in the era of high luminosity LHC. I don't want to go into details. We have seen Atlas and we have seen Alice so far. Just as a reminder, CMS is one of the two general purpose detectors at the LHC. It delivers discoveries, works on discoveries from the discovery of the Higgs boson to precision standard model measurements to physics searches. It has a high visibility and high impact, and the results shape global particle physics, similar to those of Atlas. It is unmatched in scale and technology. We all know this, 40 million collisions per second, petabytes of data per year, and this means we need an advanced detector, triggers, reconstruction algorithm, machine learning, high performance computing, and this cannot be done in a small group. At CMS, we have about 4,000 physicists working there. Brazil is embedded in CMS and embedded across CMS. We participate in physics analyses, Higgs, heavy ions, dark matter searches, exotics, electroweak measurements, etc. Detector systems where we have involvement are the RPC, GEMS, and the DT electronics, and we work also in sustainability, something that is more and more important in these times. Computing-wise and software-wise, we operate tier 2s. We have developed the Open IPMC, SDN. We work on CMSSW, which is the software framework at CMS, and of course on machine learning. So to summarize, CMS is a living laboratory of frontier physics, computing and engineering, and Brazil contributes all over the board. So as I mentioned before, CMS is one of the two general purpose detectors. It offers a wide range of physics programs. We all know this. 4,000 physicists, I mentioned this. Brazil participates at CMS with 3 institutes. I will come to them in a minute. And something that is worthwhile mentioning, Brazil is an associated member state of CERN since 2024. Currently, we are running at LHC the run 3, which is currently data taking. There are multiple major analyses underway with Brazilian involvement, Higgs analysis, standard model analysis, heavy ions, beyond standard model physics. Detector upgrades are already operational for run 3, and CMS is producing precision measurements and new physics searches in parallel. So if we look ahead, and we have seen this already in the presentation before, the future of LHC is high luminosity LHC, which will be the next decade of discovery potential. LHC will be upgraded to a much higher luminosity. We know this now. New detector components are required. New triggers will be required. New reconstruction paradigms will be needed. The huge data volumes that are expected require new computing ideas and also mean software challenges for everyone involved. This is very strong international and regional cooperation matters, and I hope I can show you how we in Brazil try to do that. So these are the 3 institutes, Brazilian institutes, that are involved in CMS. We have CBPF, National Research Lab here in Rio de Janeiro, and we have UNESP and SPRACE in Sao Paulo, and UERJ, the State University here in Rio de Janeiro. And the Brazilian groups contribute to physics, detector systems, as well as operations, software, and computing all over the board. If you want, you can categorize the contributions in 3 pillars. physics, detector, and computing. You have the contributions in physics-wise, where Brazil leads and contributes to, for example, Higgs physics, heavy ion physics, exotics, electroweak physics, dark matter, search for long-lived particles. But not only in terms of, we do not only contribute in terms of actual analysis, we also contribute in analysis coordination and combinations. Detector-wise, we contribute to the high luminosity LHC via the RPCs, GEMS, detector and deterrent, design and technology electronics, gas R&D, sustainability, hardware, QA, test stands, and we've hold several DPG roles within CMS. And finally, computing, Sprace and OERJ both have a tier 2 data center where we have data transfer infrastructure, SDN for science and networks. We contribute to the software framework of CMS. We work on alignment and calibration, physics object performance, data quality, machine learning inference, and trigger R&D. So as you can see that, I hope you can see that Brazil covers the full chain from physics to detector to computing. Let me show you some examples what we do physics-wise. Just to convince you that Brazil is present across the entire physics program from Higgs all the way to exotics and dark matter. So we contribute and contributed to Higgs and electroweak physics. We are involved in heavy ion physics, especially here at CEPF. There are searches on the way for exotics and dark matter. And as I mentioned before, it's not only the analysis that is done by students and postdocs, it's also that we take over leadership roles in terms of physics group coordination, analysis editors, internal node coordination. We work in review committees, and Brazil contributes to multiple published CMS analyses, which I will show on the slide a little bit later. I will show you now some highlights for computing and hardware, and I really have to stress that this is really just a selection. No prioritization, no ranking is involved. There's much more, but there's only so much you can fit into 15 minutes. Every institute that it was mentioned participates and contributes in a meaningful way to CMS. Let's start with the instrumentation and computing, mainly done at Sprace in Sao Paulo, where the Open IPMC board was developed, an open source controller adopted by CMS, but also in Karlsruhe at KIT, and meanwhile also at Katrin. We have Brazilian industry, which is producing boards for CERN. There is the Kitos SDN platform that was developed in Sao Paulo and is now powering international science data links. And as I mentioned before, Sprace, but also OERJ here in Sao Paulo, they both have tier 2 centers with more than 5,000 cores that are supporting CMS analysis. Highlight number 2, detector sustainability, something where OERJ is playing a major role, where we have an R&D going on for eco-friendly gas mixtures for RPCs, something that's becoming more and more important in these days. Simulations where we couple the GeAN4 and GARPID. There's a Brazilian leadership in sustainability within the detector R&D, and this is part of the global CERN efforts towards a low emission operation. Finally, the muon system and electronics, something that's done in cooperation with CPPF and OERJ. These are high luminosity LHC muon upgrade contributions via the RPC, the GEM, and the ET electronics. New link systems are developed. We try to operate local cosmic test stands and quality assurance in Brazil, and the participation in GEM alignment and the MEGA framework. And this is what I mentioned before. I don't want to go into details. This is just a list of publications from the last 10, 15 years with major contributions from Brazilian institutes. I don't want to go into details, but I want to show you that we are involved in all sorts of physics. There is search for magnetic monopoles as an exotic example. We have Higgs physics here. We have heavy ion physics over here. We have contributions to future colliders over here. So all over the board, Brazilian institutes are involved in these sort of studies. And this is also something I mentioned earlier. It's not only the contributions physics-wise and detector-wise and hardware-wise, it's also that the Brazilian CMS institutes help and hold several leading roles in CMS. So this is a very consistent thing. We have L3 convenerships, which is the lowest level of coordination, all the way to level 1 management positions, which is kind of reflecting the long-term trust and responsibility within the experiment. And this is something I want to use to close the parenthesis here, where Latin America amplifies. There are 3 things which came to mind while I was preparing the slides. On one side, there is the training, the people and training, person power and training, where a joint CLAF CERN mobility and training program is very useful. We have examples in the Latin American Schools for High Energy Physics, regional fellow and visit grants and workshops to train and retain expertise in the region should be very, very useful. Not to mention all the detector industry, we have already examples that probably can also be extended. Shared test stands and components production across Latin America laboratories and leveraging local industries. Finally, computing and software, distributed computing, SDN networks connecting that are developed by the institutes, the operation of tier 2 and 3 centers, and shared machine learning and CMSW SSW training. And finally, to summarize, I hope I could show you that Brazil is very active in CMS, that we impact CMS today, and that we contribute to the opportunities of tomorrow. There's a strong foundation. Brazilian institutes contribute across physics, detectors, and computing, not just single aspects. We make use of shared experience, national coordination, and leadership roles, reflect maturity and trust in our community. And there's something like what I call a regional vision. Together with CLAF and CERN, we can turn local excellence into a lasting Latin America presence in the era of high luminosity LHC. And if we think about the future, then we can really help shaping the future. Brazil participates in the European strategy for particle physics, in the process of the European strategy for particle physics, bringing regional perspectives into long-term plans for new colliders and detector technology. Thank you very much for your attention.
Thanks a lot, Carsen, for a very nice and focused talk. I'll have time for one question to Carsen.
Thank you, Carsen, for the nice talk. So going back to the computing development you presented for this sprays, I didn't understand where it fits in the experiment. The first bullet you presented.
Oh yeah,
I forgot the name of the.
Yeah, the OPMs.
Open IPMC. What is this?
I will send you the document for it. I cannot really stress all the details here. I will send you the document from. I'm sorry. It's not something that is really specific for CMS, right? This is really something that is can be used experiment-wide. Yeah.
In a very summarized fashion, it's a component that's needed in almost all data acquisition board of CMS. That uses is the controller of the ATCA board. of almost all data acquisition boards for CMS, which uses a particular standard which is called ATCA. So it's more DAC. Okay, it's a component of the DAC. Anyway, thanks again, Carsen.